Hey guys, so today we're going to be talking about trigonometry. And trigonometry, as you can maybe read in the objectives here, is a ratio. Now we'll be using the ratio of the side lengths to find the angle measures eventually. But the neat thing about trigonometry is it is this ratio bit. Just like any other area of math, trigonometry is very, very pattern-based. So if you can discover and if you can see the patterns in the ratios, then trigonometry becomes a lot simpler because they follow those patterns throughout everything. Now, a bit of background on trig itself. The word actually comes from two Greek terms, trigon meaning triangle, metron meaning measure. So triangle measure is actually in the name of the thing. One more time, it is a ratio of the lengths of two sides of a right triangle. I'm going to highlight that right triangle bit. Trig only works in right triangles. Okay, if you don't have a right triangle, then you need to use a different rule, which we'll get to later. But if you have a right triangle, then you're allowed to use trig. Now, the main thing I want you to focus on this slide is this acronym and these equations. Oh, and this picture. We'll be using this picture. Okay? The words explain the equations, but the equations are simpler to understand. Okay, so starting with the acronym, SOHCAHTOA is one of the best acronyms used to help remember trig, because not only does it tell you what trig function you're using, but then it also tells you the order of the ratio. And let me back up and explain that sentence. There are three trig functions, as you have probably noticed already. There is sine, cosine, and tangent. These are the three main trig functions. There are three others which we'll get to, but these are the big ones. If you can remember these three, then like I said, it's very, very pattern-based, and understanding this will be a lot simpler. Now, last thing I'm going to introduce to you before we get into the equations and the acronym is the symbol of theta. Okay, theta is a Greek letter that I will use a lot to represent the angle, because the angle when it comes to trig is very, very important. The angle determines the order of the ratio. So if I'm using angle A over here, my ratio is going to be one thing, whereas if I'm using angle B over here, it's going to be another. So keeping an eye on what theta is, what your angle is going to be very, very important to understanding what your ratio is. Okay, so that's the vocab. Let's go into SOHCAHTOA. Now again, SOHCAHTOA tells you what trig function you're using and then the order of the sides, the order of the ratio. So stands for sine of theta is equal to the opposite over the hypotenuse. Okay, and again, theta means angle. So sine of whatever angle you're using is the opposite side over the hypotenuse. And this sine of theta is very, very similar to using f of x. Okay, it's the same logic that goes into both. So don't get confused by sine of theta or cosine of theta. It's the exact same logic as if you were to do f of x or g of x. Okay, it tells you what function to use and with what angle. So sine of theta is equal to the opposite over the hypotenuse. Well, what does that mean? Here we go. So over here in my picture, if I have theta in angle A, and I want to know the sine of angle A, then A over here is going to be my opposite side, and C is the hypotenuse, and then B over here is my adjacent side. Okay, opposite means opposite of the angle. This is directly across from the angle, whereas my adjacent side is right next to it. Okay, the opposite and the adjacent sides will flip depending on which angle you're using. The hypotenuse stays the same. The hypotenuse will always be the hypotenuse. It will never be the adjacent side. So you don't have to worry about wondering that. The hypotenuse stays the hypotenuse. So in this case, if I was looking for the sine of A, it would be the sine of A is equal to A over C, opposite over the hypotenuse. However, if I was looking for the sine of B, then I put theta over here. Here's theta. Still, the ratio stays the same. It's still the opposite over the hypotenuse. But now my opposite's over here. This is the opposite side, while h is still the same. So the sine of B is B over C. And this is what I meant when I said keep an eye on theta. The ratio stays the same, opposite over hypotenuse. But depending on where theta is, your letters in the sides may change. Okay, so keep an eye on where theta is, and remember that opposite is directly across from the angle. Okay? All right, now cosine. We go over to cosine. We've got cosine of theta is equal to the adjacent side over the hypotenuse. And then the tangent of theta is equal to the opposite side over the adjacent. Okay? These are the three main ratios, and if you can remember SOHCAHTOA, you can remember the order of the ratio. Let's do some practice. All right, so here's my picture. Here are my trig functions. As you can see, I use all three of them twice. So we're going to get some practice moving theta around. Now remember, theta is my angle. So whatever is right here, this is theta. So sine of P means I'm looking at angle P. Here's my angle. Now, SOHCAHTOA, let's write that down first. Whoops, wrong letter. So sine is opposite over hypotenuse. So my opposite side is going to be 15, and my hypotenuse is going to be 17. So the sine of P is 15 over 17. The opposite side over the hypotenuse. All right, let's do another one. Let's do tangent. So I'm going down this row right here, so A, C, and E. So the tangent of P, so theta still stays the same, it's still in P. Tangent is opposite over adjacent. So here's my opposite side of 15, but then here's my adjacent side of 8. So the tangent of P is equal to 15 over 8. Now, if you have the ability to simplify any of these fractions, you should do so. All right, you should simplify, but unfortunately 15 over 17 doesn't, neither does 15 over 8. All right, last one. Actually, let's do B, so the cosine of P. Let's keep theta in angle P. So there it is, theta is still in P, and I am now looking for the cosine of P. So that's going to be the adjacent side over my hypotenuse. So I have the cosine of P is equal to 8 over 17. All right, and there it is. Go ahead, you guys, when the video pauses, try to do the sine, cosine, and tangent of angle Q. How'd you do? So in the picture, as you can see, I labeled my sides. So I labeled my opposite side as O, my adjacent side as A, and my hypotenuse as a hypotenuse. The reason why I could do this was because since I was in Q, I labeled everything off of Q. Okay, I didn't label things off of P, but I could. All right, if I wanted to label things off of P, I could say, here's my theta. I'll use blue. This would be opposite of P. This would be adjacent to P, and this is still the hypotenuse. But for right now, we're going to be using the red ones because that is labeled from Q. And here are my ratios. Now, you may have noticed, if not, I'm going to ask you to notice, that there is a similarity between the ratios. Okay? The cosine of Q, whoops, I did the cosine of Q wrong. Aha. Always check for math errors. Ta-da. All right, the cosine of Q, now that I fixed it, is the same as the sine of P. And the sine of Q is the same as the cosine of P. Okay? And what this proves is that sine and cosine are related. Now this will make a little more sense later, but keep an eye on this relationship. Like I said, trig is very, very pattern-based. When you start to see the patterns, things make sense, and as you can do like I just did and catch math errors that maybe you wouldn't have catched if you didn't look at the picture or if you didn't know the patterns. All right, let's do some more examples. All right, so here we go. I need to find the sine, the cosine, and tangent of J, and the sine, the cosine, and tangent of K. So let's go with J first. I'm going to use blue so that I can label my triangle. Here's theta in J. So this is my opposite side, this is my adjacent side, and this is my hypotenuse. Actually, it might be easier if you're still confused on how to label your triangle. Label the hypotenuse first. Okay, that way you know for sure this is at least one of the sides. Okay, so here we go. The sine of J is equal to the opposite, SOHCAHTOA. Okay, opposite over hypotenuse, O over H. So that's going to be 5 over 13. And that's it. Let's do the next one. Cosine of J is going to be equal to the adjacent over the hypotenuse. So that's going to be 12 over 13. And then last but not least, I have the tangent of J is going to be equal to the opposite over the adjacent, which is 5 over 12. Okay. You guys try to do the sine, cosine, and tangent of K. Make sure you're labeling your triangle using K. Okay? Good luck. All right, how'd you do? So you can see I labeled my triangle. The hypotenuse stayed in the exact same place. The opposite side is the side across from the angle, and then the adjacent side is the one right next to it. Now, this last little bit of the problem, okay? The first, what we just did is expressing each ratio as a fraction, or the trigonometric ratio. So if you're asked to find the trig ratio, what we have right now is your answer. Whether you have numbers or whether you just use side names, these are the trig ratios. Now, if you're asked to find it to the 100th degree, what you're going to do is you're going to take your calculator. This is a little hard to explain over a video, but I'll do my best. Take your calculator, and first off, you need to make sure it has sine, cosine, and tangent on the calculator. Okay? You'll see the little buttons of sine, cosine, and tangent. They're found pretty much on all graphing calculators and scientific calculators. Okay? Now, for this first bit, you're not going to need those numbers, but when we get to class next time, you will need those buttons, so please make sure you have them. So here I go. I'm going to do my blue ratios, and I'm just going to plug in the fraction. All you're doing right now is plugging in the fraction. So in my calculator, I have 5 divided by 13, which is equal to 0.3846, which rounds to 0.38. Now, I did my first decimal to the 4th place for a reason. The more decimal places you have, the more accurate you are. And that's just true of decimals and math. That's why we don't use decimals, actually, because it's so easy to be inaccurate. But for trig, we need them. So if ever you have a decimal, if ever you need to use decimals, take it out to the 4th decimal place for the whole problem. Okay, use all 4 decimal places for the whole problem. That way you stay as accurate as possible, and you don't accidentally round too early, which will throw your answer completely off. So always take it out to the 4th decimal place. That way you stay accurate. All right, doing the next one. So I have 12 over 13 in my calculator, which is 0.9230, which rounds to 0.92. And my last one, I have 5 over 12, which is 0.4166, and that rounds to 0.41. Actually, that actually rounds to 0.42. See what I mean about the rounding? All right, you do the red ones. Check your answers with mine when the video plays again. All right, and here's what you got. Again, keep all your decimal places out to the 4th decimal place until you're ready to round, unless, like in this last tangent, you don't have 4 decimal places. All right, now the special right triangles. So far, all of our triangles have just been regular right triangles. There's been nothing particularly special about them, meaning they haven't been 30, 60, 90, or 45, 45, 90. But now, we're going to use the trig functions on a special right triangle. So here we go. I want to find the tangent of 30. So tangent, that means I'm using TOA. So the tangent is tangent of theta is going to be the opposite over the adjacent. So here's theta, here's 30, opposite over the adjacent. And yes, there's x, but it's okay. So I have the tangent of 30 is equal to x over x root 3. Okay? Notice how when I rewrote the problem, I included what angle measure I was coming from. And I've been doing that the whole PowerPoint. The reason why you do this is to make sure that you and the person who's looking at your work knows what angle function you're starting from. Okay? All right, now I got 2 things in this. Number 1, I see an x on top and an x on the bottom. So that means eventually my x's are going to simplify and cancel out. And then I also have a root 3 in the denominator. I'm going to need to get that out. So first off, I'm going to simplify my x's, which means I'm left with the tangent of 30 is equal to 1 over square root 3. And now that the x's are out of the way, I can just deal with rationalizing my fraction. So I have the square root of 3 over the square root of 3. This is going to be equal to the square root of 3 over 3. And nothing else simplifies. So the tangent of 30 is equal to the square root of 3 over 3. All right, you guys try. What I want you to do is find sine of 30 and find cosine of 30. Go. And these are your answers. Notice how even though I had x at the first part of my equations, when I simplified my radicals, it turned out to regular numbers or regular fractions. All right, so even if the beginning looks a little weird, trust your math, trust your setup, and follow it through all the way to the end. All right, here we go. What I want you to do is use special right triangles to express the cosine of 45 as a fraction. Okay, so what I want you to do is I want you to draw the 45, 45, 90 triangle, label the sides according to the tic-tac-toe board, and then use trig. So there's a few steps involved. When the video pauses, draw your triangle. When it plays again, you'll see my triangle just so you can get the setup right, and then do your trig function. And here's the triangle. If you got it right, excellent. Keep going to the trig function. If not, make sure you fix it before you try to do the trig function. And how'd you do? All right. Now, I put the theta in my bottom angle, but considering this is an isosceles triangle, it's 45 on both angles. It doesn't really matter if you'd put theta over there or theta over here because it's an isosceles triangle. The sides are the same. All right, otherwise you need to be very careful with where you put theta, but since it's an isosceles triangle, you could have picked either one. You should have gotten the same answer. All right, that is it for today. Let me know if you have any questions, and I will see you next time.